Do, do, do. Oh, okay. I think this should be live. Um, um, hello. This stream today usually will plan to be A-level maths instead of GCSE. But because GCSE paper ones are right around the corner, I think there's still quite a while for A level the papers to kick in. So I thought what I'll do is today I'll change this to a GCSE uh, revision stream and then do an A level one in place for a GCSE stream in the future. So I'm kind of switching stuff around to be a bit more like sensible. So anyway, today the aim is, like I've done the last few streams, to help with paper one come in on Thursday in 3 days. Is to go over a past paper. And obviously the idea is to go through it blind, go through it uh, question by question, all in one, and then basically just go over how you should think about the question, how you approach, how you work stuff out. Um, and hopefully it should be of help. And obviously I'll try and explain the stuff as I go along as well. Anything that might help. But that's the aim. So to just go over past paper. So I did 2018 and 2019. Obviously those were before the pandemic. I started to go over the recent one, the 2023 today paper. I can't see 2024 up there, so we start with 2023. However, this will still be good practice, and yeah, so this is the non-calculator. Um, and yeah, I guess without further ado, let's just get started. Okay, so question one. Um, Work out 8.46 divided by 0.15. Coincidentally, this is one of the topics that I strongly predict will come up on the non-calculator, mental arithmetic, either multiplication or division. Today it's division. I strongly predict it will come up. I did a video about it, division, a few days ago. Yeah, let's do it now. So, 8.40. So the thing you want to do with division, 8.46 to 0.15, it's best to first, especially when you have decimals anyway, it's best to write it as a fraction. Because remember, a division, A divided by B, is exactly the same as saying A over B. And that's what a fraction is, ultimately. So yeah, you write it as a fraction. And the reason why this is good is you want to get rid of the decimals for both numbers, right? And the way to get rid of decimals is by timesing by 10. So to get you want to you're going to need times by 100 to move 2 points. So times by 100 over 100. This is now the same fraction or division as 846 over 15. Move 2 decimal points because it's 100, 2 zeros. Same here. You have to do the same to top and bottom because these are equivalent fractions, right? These are equivalent because I'm times in the top and bottom are the same. And the whole idea is to get rid of the decimal point. That is why writing the division as a fraction is very helpful here. And so actually now all we need to do is actually work out 846 divided by 15. And for this, I just recommend the bus stop method. So the denominator on the outside, the numerator, the top number in the middle. And so then you do your usual bus stop method. So go digit by digit and divide 15. And so 15, how many 15s going to 8? None. So then how many 15s then go to 84, the next digit? Well, got a 15, 30, 45, 60, 75, and then 90, but on 90 would be going over. So 75, so 1, 2, 3, 4, 5, and then a remainder of 9, right? So you'll then have 96. Yeah, 9. And then 96. Well, continue this on. 75, 90. And then 96, you'd be going over. Um, so then, how many times was 15 going to 96? Well, 1, 2, 3, 4, 5, 6. And because there's no more numbers, you have to add a 0 and then carry the 6 up here. But, I'm sorry, put a 6 here. 56 point. Because there's a remainder of 6, 90, and then get to 96, it's 6, and a remainder of 6. I need, and because there's no more numbers here, you're going to need to add a point and then add the remainder 6. So now and add a point here to have to match, right? The digits have to match. So, how many 15s then go to 60? Well, 4, right? Exactly 4. 1, 2, 3, 4. So point 4, no more remainder, so we can leave it there. And actually, that's our answer at this top number here, 56.4. And because this is equivalent to the original division, we don't need to adjust the decimal. That is exactly the final answer. And that is exactly how I recommend approaching these division questions. If you, I strongly predict this type of question will come up. The first question or so. So yeah, if you're not comfortable with it, and this is for both higher and foundation, it applies to absolutely everyone. I do strongly recommend you look into it. But yeah, that's how I'd approach that sort of question. Question 2, I also predict a fraction question like this will come up. Like I said, but both of these have come up on loads of past papers, so chances are it's going to be on your paper. So now we got a fraction one. So these are mixed fractions because there's a whole number and a fraction. So if you want to do stuff, the best thing I do to recommend is to firstly convert both of them into just a fraction, so an improper fraction. So 3, 8, 7, 3 over 8. Well, convert that into just a fraction form. Times the whole number by the denominator. 7 times 8, which is 56. And then add the 3. So 59 over 8. Likewise, 2 and a half, 2, 1 over 2. Times 2 by 2, 4. Add the 1, 5. So it'd be 5 over 2. So therefore, this fraction is exactly the same as doing 59 over 8 minus 5 over 2, because these two are exactly the same fractions, right? Okay. Well, when you're adding or subtracting fractions, they have to have the same denominator, right? But actually, you should notice 2 goes into 8. And actually, so 8 should be our denominator here. So how to get from 2 to 8? Well, you times by 4, right? 2 times 2 times 4 is 8. So then to make you have to do the same to 5. So out of 8, 5 times 4 is 20. And now they're both exactly the same denominator. So now we can simply subtract the top number. So 59 minus 20 gives us 39. Make sure to clear that 50 and not 3. 39 over 8. Then it says to give it as a mixed number. So then we need to convert it back to a mixed number. So how we need to do that, we need to look how many 8s go into 39. Well, 8, 16, 24, 32. 4 times, right? Then it would be 4. So you put 40 goes over the 39. So 32, so 4 times, right? 4. And then it's kind of like a remainder of 7, right? 7 over 8. And that is how you convert it. And that should be the final answer, right? Mixed number. Mixed number is both a whole number, the whole and the fraction. Okay. That's if you practice your fractions, that's a very standard question. Hopefully it shouldn't be too bad. But yeah, again, I was strongly. I pretty much bet like 99% there's going to be a fraction question like this on the non-calculated paper for both papers, higher and foundation. So this is a really good thing to learn. I recommend to get the marks. Okay. But hopefully it made sense. That's how I'd approach this sort of question. Always, uh, you, the, the, I think there are ways you can just do it if you're really, really confident. to just leave it in mixed form and subtract. But the safest approach to convert into improper fractions. Let's subtract like normal. Okay. But yeah, that's how I go about that. Then it says question 3. A cube has a total surface area of 150. Work out the volume of the cube. So, surface area you need to remember is if we sketch what a cube looks like. Uh, there we go. Bit rough, but you get the point. The surface area. Well, it's how much of the area, how much of the surface, right, that we see. Which, in other words, the surface area is just the area of all of the faces of the shape. So this face here, this face on top, there'll be a face on the bottom, there'll be a face on the back, and the faces on the side. And actually, you notice the faces are just 2D shapes. Because basically, all of 3D shape is just a composition of 2D shapes. Look at a cylinder, for example. We did this on the other paper. Cylinder looks like that, right? A bit dodgy. But really, it's just a rectangle on the front, and stuck with two circles. So really, it's just 2D shapes composed together. And that's how we work at surface area, because we work at the area of all the 2D shapes on the side, on the faces, right? And that's all it is. So a cube, well, a cube is like a square in 3D. So a cube means all the side, all sides, the length sides are the same, and the same length in particular. So it's like a square, right? Square, all the sides are the same. Cube is exactly the same. It's just the 3D version. Anyway, so I think it's a good idea to try and work out the surface area. Now, because all sides are the same, if you just label the side X, they're all going to be X, right? X, 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 X. Every single side is X. And because of that, all the sides are the same as well. So one side is simply a square, X, X. So really, how many sides are there then? One at the front and one at the back, that's two. One at the top and the bottom, that's four. And then one on the side here, and then on the other side, that's six. So if we find the area of one square at one side, which and then times by six to get all the sides, that is the surface area. Okay. So then, what's the area? Area of one square face. Wow, it's going to be x times x, isn't it? It's going to be x squared. Therefore, surface area is going to be 6 times that. So it's going to be 6x squared. And we are given that surface area is 150. So that means 6x squared has to be 150. So x squared has to be 150 over 6. Okay, which would be 25. You can kind of spot this because x squared, it kind of has to be an integer, right? And it has to be a square number because it's x squared. 25 is the best guess here. Check this, 25 times 6 indeed gives you 150. So x is 5 centimeters. The side is 5, not minus 5. You don't do plus or minus here because minus 5 doesn't make sense because it's a length. You can't have a negative length. So you just take the positive of 5. Okay. Well, we know we know the surface area, so now we know the volume. Well, the volume is, you should know, of a cube is simply x cubed. So it's all the lengths, the width, the length, the length, the width, and the height. Okay, so you times the side length 3 times, so it's x cubed. Now, actually, you know what x cubed is, so it's 105 cubed, which is 5 times 5 times 5, which is 125. And that is your answer. Okay. Lovely jubbly. Okay. The table shows information, daily rainfall. Then it says to draw a frequency polygon. Okay. So a polygon, this is just something you need to know. A polygon kind of looks like this. So you draw points together and you connect them by a line. So it looks kind of like that. But how do we plot these points? Well, it gives you a kind of clue here, really, if you get stuck. The rainfall against frequency. So you might think, well, plot the rainfall and then against its frequency. Well, the frequency is it's just one number. That's easy, right? However, the rainfall is grouped. It's not just one number. So actually, what makes the most sense here to represent this is to do the midpoint. So if you want to, midpoint, just write down the midpoint of all the groups. Well, actually, that's going to be 2.5. What's between 0 and 5? 5 and 10 is 7.5. 10 and 15, 12.5. 15 to 17.5. And 22.5. So now we're plotting the midpoint here against the frequency. So 2.5, which would be here, against 8, which should be about that, right? Then we have 7.5, which should be here, against 24, which should be about there. And 12.5 over 13, which should be about there. 17.5 then over 11, which should be there roughly, and 22.5 and 4. Okay, cool. So now what you do is you just plot them as a straight line. So use a ruler for this, but I don't have one, unfortunately. So I have to do the best. Draw a line that connects each of the dots, right? Straight line. Oh god, there. But make sure you make it neat with a ruler. I believe that should be the answer, right? Let me just double check that. Okay, it doesn't give you the drawing in the mark scheme. It gives you yeah, that should be fine. Yeah. Okay, cool. Okay, so that's just something you need to know. Frequency polygons. But they give you a lot of help here. They give you even the axis and what to plot. So you know you're going to have to plot the rainfall against the frequency. But the frequency is a whole number. That's pretty easy to work out, right? Unlike the x, y axis. But the rainfall, obviously, you get it's a lot. It's grouped. There's multiple numbers. So usually the best bet with this is to plot the midpoint, which is what we've done here. That's a strategy. Okay. You just need to recognise this is what you need to do with frequency polygons, but it's easy marks. It really is. Once you learn polygons, it's fairly straightforward in my opinion. But there we go. Venn diagrams. I do like Venn diagrams. Here we go. So this funny number here. Now this funny number. Let's just. I remember I was a bit confused with the GCSE, but let me just give a little explanation. This funny letter means something called the universal set. For each set here, so A is a set, which is encircled, B is a set, and we put items into each set if they belong to it. So, for example, A, let's do A. So, A is an odd number. Well, which ones? So, the universal set contains all items, right? All the things we are interested in. And what we need to do is put each number into these sets, right? So this box here, you notice there's the same funny symbol again. That's the universal set. So this box represents all the items we have. Okay, everything. Nothing can be outside the box. So everything has to be contained in the box. It's universal, so it contains everything. So that's all that funny number means. It's a funny letter even. It's just a funny symbol for representing a universal set. The set that contains everything. A list that contains everything, right? See, it's a list here. Anyway, so A, which is another set, uh, must be odd numbers. So from this list, what are the odd numbers? Well, you should spot easily. It's 1, 2, uh, 1, 3, 5, 7, 9. And then that's it. The rest are even. And B is square numbers. So the best way to fill in a Venn diagram is actually to look at the intersection in the middle. Now, if they cross over, they have to be in both lists. Okay. So from the odd numbers, I write it down even. Odd is 1, 3, 5, 7, 9. We also need to consider the numbers that are square numbers. Now, square numbers, well, simply 1, 4, or 2 squared, 1 squared, 2 squared, 3 squared, 4 squared, so on, which is 1, 4, 9, and then it doesn't go beyond 10. Okay, now, okay, so what numbers go in both of these then? Well, 1 clearly, right? 1, and actually 9 as well. We can cross them two out. So then let's look at odds. The only other numbers are odd, but not square, so only in A. That's going to be 3, 5, and 7. And the only square number that isn't odd, well, it's 4. That's the only one on the list left. So that's the idea with Venn diagrams. Look at the intersection and then work your way outwards. So look at what's in both of them, what numbers fulfill both of these requirements, go in both of the list, and then look at the numbers that are only one of the list, and then cross them out. And so, but there are more numbers here. So, obviously, that's not all of them. So, the universal set. So, the number outside of these two sets have to be the remaining numbers that go inside this space here, outside of the circle, but inside the rectangle. Um, okay. So, 2 isn't in any of them. Uh, fr- uh, 1 is, obviously 2 isn't, 3 is, 4 is, 5 is, 6 is not, so it has to be outside. What about 7? That's in there. 8 is not in there. We put 8 here then. 9 is, and 10 isn't. So 10 would be, you put it there, it doesn't matter where. As long as it's outside the circle, but inside the box, okay? Okay. So this is a way of representing the numbers in these lists, okay? So you can see which numbers are odd, which numbers are both odd and square numbers, which one's just a square number, and which one is neither, okay? But you have to include all of them because it's universal, right? All the numbers have to be included. Okay, so that's just a rundown of what Venn diagrams are and how to fill them out. That's 3 marks, nice for that. Then it says a number is chosen at random from the universal set. So yeah, universal, that's what that means. From the set, so from this box here. So all the numbers we have. Find the probability the number is in the set B prime. Okay, so there are various things you need to know about sets, but B prime means not in B. So not in the list or the set B, not in the circle B. Okay, well, probability there means what we want. Very general terms, very simple terms, but it's what we want over the total number. Okay, so numbers not in set B. So a number is chosen from the universal set. So the total numbers to choose from is 10, right? Because there are 10 numbers to choose from, so it's going to be out of 10. No, it's there's 10 numbers. We want a number that's not in B, which is what this means. B dash means not in B. So, how many numbers are not in B? So almost you can kind of, if you wanted to, I don't recommend it, but if you have to visualize, shade it off. Actually, no, that's not how you should shade. Actually, uh, you can shade the parts that are not B even. So do the other way. So obviously, everything's not in B. It's going to be the whole rectangle and just A, but not the intersection because intersection means it has to be part of B. Still, okay. So these are the regions we want. Everything that's not in the circle B. And actually, how many numbers are there? 1, 2, 3, and then 4 outside. 4, 5, 6, 7. So out of 10 numbers to choose from, 7 are not in B. So that is your probability there. Okay, we can't simplify it, but even if we could, it doesn't matter. That's the answer to that. Very nice question actually, especially if you love Venn diagrams. Really lovely question. Okay, so question 6. So scatter graphs show information age against weight. So describe the relationship. So okay, for GCSE anyway, the relationship between something. Uh, what that means is if we change the age, what happens to the weight? That's what we mean by relationship. They're variables, right? So if you think about the science, even independent variables and stuff like that. So if we change the age, what happens to the weight? Well, if the age, look here. If we increase the age as we go up here, if we go across the x-axis, the weight goes up as well. So it looks kind of like this, like a line of best fit. As age goes up, so does the weight. What we what that means is it's a positive correlation. So the relationship is this means as the age of the babies increases, their weight increases. And this is a positive correlation. So there's three types of correlation. One where the points generally go up. So if one goes up, so does the other. That's a positive correlation. On the flip side, if the age, say if the age increases but the weight goes down, say if the points follow this pattern, that's a negative correlation. And you see it's going down, negative. So as one increases, the other decreases. That would be negative. If they both increase, then it's positive. If they all scatter together, there's no real correlation. Say if the points look like this are all over the place. There's no real trend. It doesn't go up or to go down. It's no real trend. There's no correlation. Okay. But for GCSE, you just need to spot if there is a correlation, if it's positive or negative. Okay, and this one is positive. So what that means, as I said again in the context, as the age goes up, so does the weight. And if you think about it, that makes perfect sense, right? As a baby grows up, obviously they get bigger, so then their weight's going to go up. So just think about that, and if you think about that in that context, it makes perfect sense. Okay, so then it says another baby has a weight of 5.8 kilograms. You've used the scatter to find estimate. So what we can do here is, if because they've genuinely followed a pattern that which is positive correlation, they go up. We can draw a line of best fit. Now, I won't be able to do this accurately. I know I won't. Because unfortunately, I'm not got this on paper. I'm on digital. I don't have a ruler or anything like that. So this is going to be quite a bad one. But generally, you want to draw best fit so that half of them are the points on one side and half on the other, roughly. Uh, so oh no, that's not curved. You don't want it curved. So something vaguely like this. See, roughly half on the bottom, half in the middle, and then some on the above the line bottom, and some on the line. That's roughly the line of best fit, but obviously made that better. So what this line of best fit does, it essentially is an equation, it's a formula, right? It's like a graph, so y equals x almost, right? If you know the age, you can use the line to work out the weight and vice versa. Well, actually, that's what we're going to do because it says if we have the weight is 5.8, so 5.8 is going to be this point here, this here, and then we just read off the line. So, oh God, I didn't want to delete that. That's a rubbish line. Still a bit rubbish. Though something vaguely like that. So, if we continue, then if we follow the corresponding age, if we go down here, is here. Well, roughly that's 3.6, right? The age is 3.6 months. Now I don't think that's going to be right purely because I can't draw an accurate enough line. I can't draw an accurate enough line the best fit, but if you use a rule and stuff, it should be more clearer. So they accept a lot of range actually. They accept between 2.5 to 4.5. Well, actually, we're bang in the middle there, so it's not a bad job that is actually. So yeah, that's how you go about that. If they ask you stuff like this to estimate, if you give them the weight to find the age or vice versa, draw the line of best fit. That is the whole idea of line of best fit. But if there is a correlation, that means we can draw a line that kind of puts all the points together. Right? So we could estimate all the ages to the weight because there is some sort of correlation. There's a link between the two variables. This line represents the estimated link. So this line we can use to estimate the weight or the age, vice versa. And that's the whole idea of line the best fit. Okay. Right, yo. Question 7. The price of holiday increases by 20%. This 20% increase adds 240. Okay, so the best thing with these type of questions, I'd love to choose in letters. So, what I mean by this, so the price of holiday increases by 20. The 20% increase adds 240. So what this is saying is, say the original price is X. So X is the original price. This makes it a lot easier to visualize and write down, I think, at least in my experience. Let X be the original price. Now, actually, kind of just then follow the step that the process is giving you. So then we increase it by 20. By 20% is the same as 1.2. A 20% increase, anyway. So 20%, if you increase the number by 20%, that's the same as times it by 1.2. So 1.2x represents a 20% increase of the price. Okay. Now um this 20% increase adds 240. Okay, so 20% of x. So it's asking us to find 20% of x, not the 20% of x is 0.2x. Okay. and it's telling us a 20% increase, 20% is 240, right? So now we just solve for x. Now x is the original price. It's asking us the price before the increase, the original. So x is what we're after here, the original price. Just bear in mind what it means. So the wording is crucial here. It says 20% increase adds 240. So if we're adding it, that means we want the 20% has been added. So that's that's 20% of x, not 20% plus x. If it said 20% increase plus the original price is say 600, then yeah, you're going to want 1.2x because that represents the original and the 20%. But here it's just telling us the wording is crucial here. The 20% increase, the 20% increase adds 240, so it's adding it to the price. So this must be what we're increasing it by. This is what we're increasing x by, okay, which is 20%. So 20% of x is 240. Hopefully that's clear. Hopefully I didn't waffle too much there. Okay, now we just solve for x. So what I would like to do here is, well, 0.2 is a fraction, right? You should know 0.2 is 1 over 5. That'll make life a lot easier. A fifth x is 240. So if you times by 5, you get rid of this fraction here. So for x then is 5 times 240, which is 1,200, is it? Yes, 200 times 5 is 1,000, and then 40 times 5 is 200. So add them together, you got 1,200. Cool. I'm not pretty confident in that, but I just want to show how you can check your answer if you're not the most confident with your arithmetic, or if you're really unconfident, use long multiplication here. It could throw some people off. But obviously, you times it there, do the process. You should know how to do long multiplication, but yeah, so you can work that out, and that's your original price, 12,000, right? And that's how I approach that with these sort of. This is the approach I love doing with these unknown, like these unknown percentage problems. They want you to find the original before you increase or decrease something. Just use a letter, use variable, use a letter to represent the original, and then it easily follows, right? I think this makes logical sense. Rather than trying to like go backwards and try and be problem solve to try and reverse it all. I feel like that's more prone to make mistakes. I feel like this makes more sense to follow. If you're just comfortable with a bit of algebra. Don't, I always say with problems and questions like this, don't be afraid of algebra. If you don't know about something, just use a letter, and then it should make things easier. Really, that's my approach with this. Always let x be the original price. Use a variable, use anything, and then go from there rather than trying to go backwards and try and like reverse engineer and try to be a bit more clever. Obviously, if you like that, then go for it if you're confident. But if you're a bit unsure, I like going for this approach instead. But anyway, we'll leave it there. Diagram shows a solid cylinder on the floor. So imagine this is on the floor at this base here, and it's sticking up. Okay, we're told some information. The cylinder has a volume of 1,200 and the height of 40. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. Okay, so we're given the formula here. You'll always be given the pressure formula. The way this works with pressure is, like I said earlier, these shapes are just composed of 2D shapes. Really, the 3D one. The circle here, and a rectangle. Now, it says it's on the floor, so this will be on the floor, this bit. Now, the pressure is on the floor to the cylinder. So, where does the floor meet the cylinder? This shape here, right? This is what, almost think about the like the front elevation, right? You see what the floor would see, and you'd see this circle bit here and the bottom, the base, right? The base. That is what the floor will come into contact with, and that is the area you're going to want. Is the area of the base circle. That is the area we're interested in, and that's what the force and the pressure is acting on, not the whole shape, just this base circle here. So our job is to find the area of the base circle. Because once we find that and we're given the force, we can find the pressure. So that's what this question is. Well, obviously we know the area of a circle is pi r squared, the radius. So now we just need to find the radius. So we're given some information. Volume is 1200 and the height is 40. Well, you should know the volume of a cylinder, right? So volume of a cylinder, that's going to be pi r squared h. Right, okay. And actually we're given we're given the height and the volume. So therefore 1200 or 1200 is pi r squared times 40. So therefore 1200, or not 1600, equals 40 pi r squared. Okay. Now you might be tempted to find r. So you'd want to divide by r at pi and then square root. However, uh, however, that will clearly, because there's pi and pi is a dodgy decimal, not 3.14 something. It's irrational, goes on forever. We cannot do this on calculator and get a nice number. We can't. And actually, there's no. The question clearly wants us to give a whole number. We want the exact answer. It doesn't say in terms of pi, so that's telling us here that actually we shouldn't need to compute this calculation, and it'll get a decimal. We don't need to do any of that. So actually, we need to find a way of avoiding that calculation to just get radius. So say maybe we need to find the radius. But notice here, and this is staring at me, the area is pi r squared. We have an expression for pi r squared here, don't we? What if we just said pi r squared by a bit of rearranging is, well, 12,000 over 40 divided by 40 both sides. That will give us the area, right? This is the area. And so actually then we can work this out easily. So get rid of 0, 120 over 4. Well, that is going to be 30, right? 30, 60, 920. 30. So the area is 30. Therefore, if you go back, the pressure is, I believe, force over area. Well, the force is 90. And the area worked out is 30. So that's going to be 9 over 3, which is 3. 90 above 30 is 3. So that's going to be 3 newtons per centimetres. And there is your answer. Lovely jubbly. So, a few key things to note with that is A, you need to know what the pressure is and what it's acting on. So if this is on the floor is going to meet the base, isn't it? That's how it's going to meet the cylinder. The base is this circle here at the bottom. That's the area of this circle here. And two, you need to know that actually we shouldn't, and we can't actually find radius without a calculator. Not exactly. We can't divide by pi, and it doesn't say to leave it in pi either. So we need to be a bit more clever here, and actually you should spot this. The area is just this bit here. This is how we can avoid nasty numbers, because the question clearly doesn't want us to have nasty numbers in. Okay, if it did, it would say something like either leave in terms of pi your answer, or give to I don't know, 2 decimal points. But obviously you're going to need a calculator for that, so that's a no-go. And leave in terms of pi, it didn't say that, so that's how you know. If you're trying to find the radius and you obviously can't without a calculator because it's going to be dodgy numbers, that you shouldn't. It's not. It's not the question. Not expecting you to do that, so you've probably gone wrong somewhere. So just be careful of that. That's quite a trip up. I feel like for some people, they'll probably think, "Oh, I need to find the radius to solve it and then sub it into there." But that's not what the question wants you to do here without a calculator, anyway. Okay, here we go again. 9. So we got 2 lines drawn, and it asks us to solve the simultaneous equations. 2 minus 2y is x, and 2y equals 3x minus 20. Well, coincidentally, both of them, the exact lines, are drawn for us already. So if we're using the graph, the solution when both of these happen is that where they intersect. Because when they intersect, their y and x coordinates, x, y, are the same. That's when they equal each other, right? And that is why when you solve simultaneous equation, that's why you substitute as well. So say x is, if we were to solve this algebraically, x is 2 minus 2y. That is why you substitute this x into here to get y and solve it that way. That is what substitution is doing. Because when they intersect graphically, their coordinates are the same. Y and the x are the same for both of the lines. That's why you substitute one line equation into the other. That's exactly what substitution is doing. And that is what intersection is. It's the solution to both these equations when they intersect. You need to recognise that key link there with the graphs. So, to solve it, that's the point of intersection here. You just need to read off the graph. And actually, the x coordinate is clearly going to be 6. And the y coordinate is going to be there, which is minus 2. So actually, it's going to be x is 6 and y is minus 2 for 1 mark. So you just need to read off the graph there. Okay, lovely, lovely. Okay. Okay, here we are. Here we are given a pentagon. A very key point here. It doesn't say regular pentagon. So you have to be careful here. So not all the angles or sides are going to be the same. But that's just something to note. Angle AED, that's just something that jumped out to me. But anyway, it says angle AED. Now, AED is this angle here, lovely. We call this X then. It's 4 times angle ABC. So actually, I think it's best. No, call that X. So AED, angle AED, which is this angle here, is X. Then, obviously, this angle, ABC. Well, if it's 4 times ABC, that means ABC has to be a quarter, right, of AED. So that's how we represent it. Okay. Now, actually, we've got all the angles apart from one, really. One unknown. And then we've worked out all of them. But it tells us it's a pentagon. And it tells us all the angles for a reason, interior. So, one thing you do need to remember is actually what the interior angles sum to in a pentagon. Or what shape in general, actually. There are 2 ways. Well, they're the same way, I guess. There are many ways, actually, probably. You can learn what the interior angles add up to. The one I like to do is just recognise this pattern here, and it only takes a few seconds. If we know the triangles add up to 180, that's what you need to know. And you know a square, which is 4 sides. Oh, God, that doesn't look like a triangle. And you know a square is 360, which you should also know. 4 right angles. Well, a pentagon is 5 sides. That's going to be next. So 3 sides, 4 sides, and then pentagon is 5. Follow this pattern on. So clearly we're going up in 360. So the pentagon is going to add another, no, 180 is going up in. A pentagon then, to get the angles and that, is going to be another 180. So if we continue this on, well, 360 plus 180 is going to be what? 540, right? So actually, the area, all these angles have to add up 540, and that'll be for every pentagon as well, not just a regular one. But that's what you need to know. And another way I see people just learn this formula. So what was it? 180 plus n minus 2 uh, plus n minus 2 lots of 180. Essentially, if n is the number of sides, you plug that in, and then it's a formula to give you how many interior angles there are. But this formula, or something similar, you can simplify this, but it's the same one you might see in class or whatever. This comes from this sequence here. That's all it is. For any formula you may remember for the interior angles for a shape, four-sided, five-sided, six-sided shape. It all stems from this sequence here, the simple one. If you notice the triangles are 80, you should remember these two off the back of your heart, really. A triangle angles add up to 180, a square one adds 360. Follow the pattern. So then that's three shapes, four shapes, and five sides, and six sides, and seven sides. Keep adding 180. I think that's the simplest way rather than just trying to learn a specific formula with n and stuff like that. That's how I remember it even now. I don't remember that formula. I can derive the formula because of this pattern here, but that's how I remember how many angles it should add up to, right? So anyway, so 540 has to be the sum. I'm getting a bit sidetracked now. Has to be the sum of all of these. So that would have to be 120 plus 135 plus 110 plus this x here plus our quarter x. Okay. Oh God. Interesting question. It looks like actually. Okay. So now it's just solving for x, right? So let's add these up together. So I think the best way, if you're a bit unsure, let's do this in the head. But if you that'd be 335, 355, 365. Add x plus a quarter x. That's 1 plus a quarter, which is 4 over 4 if you get the same denominator. Add 1 over 4, which is 5 over 4. Okay. If you were unsure, because it can be quite heavy, this addition here, just do column addition, right? Do 120, 135, add 110, 5, 0, 0, 2, 3, 1, 6, 1, 1, 1, 3, 365, okay? That's it. In a non-calculator, don't be afraid to use mental methods to work out sums like this. And that's 540. And then you subtract 365 to both sides. Um, okay, so what would that give you? Again, if you're unsure, use well, I'll do it here actually to demonstrate. Use subtraction. So zero, oh dear, sorry, 0 minus 5. Well, you can't do that. You don't want negatives, so you have to borrow from here for 3, and then bring the 1 out. 10 minus 5 is 5. 3 minus 6, well, you can't do that. That'd be negative. Change it to a 2. Oh no, sorry. My apologies. Change this to a 4 and carry the 1. 13 minus 6 is now 7. Now 4 minus 3 is 1. So the answer should be 175. Let's check that. 100. Yeah, that should be right. Okay. Okay, 175 is 5 over 4. Oh, dear. 5 over 4x. Really weird x. And then you want to get x on its own. So the best way is to times by 4 over 5 times 175. Okay, the reason for that is, well, 5 over 4 times 4 over 5, they cancel each other out. So you're just left with x. So that comes 1. 1 times x is x. Hopefully that makes sense. Now this seems tricky. However, 5 clearly goes into this because it ends in a 5. What's 175 divided by 5? Again, though, this is really intense. This really assesses your mental arithmetic. Um, okay. 50, 10, 40. I believe it's 35. So 175 cancelled to 5, 35 times the 4. Should be 140. That should be. You can check this again if you're a bit unsure. 175 divided by 5. Do a quick bus stop. 5 doesn't go to 1. 5 goes into 17 3 times, with a remainder of 2. 5 goes into 25 5 times. So yeah, 35, so we're right. And then obviously 35 times 140 times 4 gets you 140. You could do long multiplication if you are a bit unsure. But there we go. So that's x. X is 140. So it says to work at AED. Well, angle AED is x. So x is our answer here. 140. Okay, so that's how you go about that question there. Yeah, that's the right answer. Yeah, so I don't think there's not too much you need to remember here, rather than other than the angles. I think the difficulty with this question is just the intense amount of arithmetic you need to do. It's very intense actually, but once you get through it, it's 140. That's the process behind that. I'd say the tricky thing with this, the hardest thing, is just getting through all the arithmetic and not making an error. But you can make sure you don't make an error by using mental methods like this. Bus stop method, column addition, subtraction, vice versa. Okay. Lovely jubbly. We are now on question 16. 11, sorry, not 16. I saw the 6 here and the 1, so I thought 16. Anyway, write this in the form ax to the b, y to the c. So it very clearly looks like an in-depth form question, right? There's loads of indices and stuff like that. So they made this very, 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 very complicated. Very, like there's a lot there. Okay, there's a lot going on. But break it down and remember your index laws. Remember, and there are only three you need to know really. A to the n times a to the n. If same number, add the powers together. If you're the likewise dividing the powers, you subtract them. So dividing the numbers, you subtract the powers. And if you're raising something to one power with by another, you just times them together. Those are the three you need to know. That's all you need to do with this. Now, let's break this down. Firstly, let's deal with let's deal with the coefficients. Let's deal with the actual numbers. So, what we have here then, so 6 x to the 5 y cubed squared over 3x squared y to the 7 times 4x y to the minus cube minus 3. Okay, we have numbers going on. We have x's and y's. So let's think about them one by one. Firstly, let's deal with the 6. So 6 something squared. Let's make them all the same, right? Clear, let's expand this bracket first. I think that might help. So, like with this formula here, if we're all raising all of this to the power 2, we can raise everything individually by 2. We can times the powers. So this is going to be same as 6 squared, 6 1. Remember this got 6 to the 1 almost. 1 times 2. If we put the expand it, 2 is going to be 6 squared. X to the 5 times 2, which is going to be 10. Y to the 3 times 2, which is 6, with the same fraction. Okay. Now, I don't like the look of this denominator here. I don't. I want to bring it all as one, like this one. So this one's on its own now. I want this to be on its own. So I want to group these two together. Uh, so let's have a look at this. 3x squared y to the 7 times 4 x y to minus 3. Let's do this individually. So let's first times the and bear in mind this what this is saying almost is the same as 3 times x squared times y to the 7 times 4 times x times y to the minus 3. Because if we remember with algebra variables, if we put them together, there's a secretly times in them. So all we're doing is timesing everything together. So with that in mind, let's break this down part by part. So let's do the number first. 3 times 4 is 12, so we dealt with that bit. Now let's do x. So x, we have x squared times x, which is 1 power there. Now, we're going to refer to, if we're timesing, we add the powers here, right? So x squared times x to the 1, that's going to be x2 plus 1, which is 3. Likewise with the y, if we're times, we're going to add the two y powers together. 7 minus 3 is going to be 4. So this whole denominator is simply this bit here. 12x cubed y to the 4. Now 6 squared, we know is actually 36. X to the 10, y to the 6. All over 12x cubed y to the 4. Okay. Now, again, we're dividing, so we refer to this one here. Again, like with this, let's do the number first. What's 36? Oh dear. What is 36 divided by 12? Well, that's going to be 3, isn't it? Then let's do x. X to the 10 divided by x to the 3. Again, with here, for dividing, we subtract the powers. So 10 minus 3 is 7. And lastly, y. Well, y to the 6 divided by y to the 4, you subtract 6 minus 4. Well, that's going to be 2. And that is going to be your final answer there. Okay, and it's in this form that they want. Okay, there we go. A is 3, B is 7, Y is 2. Lovely jubbly. So it looks like a whole mess, but really it's just testing the index laws. So if you, even if you just write them down, if you remember, and you take your time, the question isn't the worst in the world. It just looks a mess. But once you break it down, work through it bit by bit. If you just stare at it as a whole, oh God, what do I do? You're going to freak out. Deal with the top bit first. Deal with the bracket first, which would be this law. Then you simplify the denominator, or basically use big maths almost. Then you simplify the denominator to make it as 1, and then it all follows, right? It follows quite easily. So you know we can use this law to deal with the bracket. Then you can times it with this third here, and then this is a lot more manageable, this division here. And then you use this law here. That's how I approach problems like this. Do it bit by bit. Don't look at all of it. What do I do? And freak out. Just remember what you know. Even write it down if you have to. Recognise the topic. So clearly it's going to be index laws because there's so many indices and stuff like that. And then do it bit by bit with what you know. And then hopefully at the end, you can actually get somewhere. Okay. That's my advice with stuff like that. Okay. Well, question 12 now. Martha, so we've got a tree diagram, so probability question. So she plays the game twice, which is here. The probability shows the probability she wins or loses. Find the probability that Martha will lose at least one game. What does that mean, at least? Well, the wording is crucial here. She loses at least, well, at least once. So, what does that mean? If she played 2 games, that means she has to lose one or both games. Okay, notice this or here. So, what we want is the probability she loses one game or probability she loses both. Now, the or is key there because remember, or you add them, add probabilities, and you times probabilities. Because we have an or here, that means we want to add them. Okay. So what we want to do, so when it says at least one game, well, what are the events that can happen? She can either lose one of them, at least one, or both of them, but she can't lose none because that then wouldn't be this. Okay. So one of the probabilities she loses one of them, or she loses indeed both of them. So again, break it down. Let's look at if she loses one. If she loses one game. Okay. Well, that means she's either going to win the first game, but then she'll have to lose the second one to make sure she loses once. So that's going to be 5/8, and then she loses the second one. So and is times in. Okay. Let's work this out. 5 times 7 is going to be 35, and then 8 times 9 is 72. Or she loses the first game, but then wins the second. So that's going to be lose and then win. 3/8 times and then wins the second one. 2/9. That's going to be 6/72. And then we add them. So that's going to be, and they're the same denominator, so we can just add as usual. 35/6 is going to be 41/72. That is if she loses one game. Okay, so she either wins the first one, then loses the second, or then loses the first and wins the second. Okay, no doubt that. But now, what if she loses both of them? That's one of the situations she could have, right? Well, simply if she loses both, that's going to be lose and lose. So it's going to be 3/8, and the second. She loses the first one and the second one. So 3/8 times 7/9. 3 times 7 is going to be 21 all over 72. That's it. So that's only one way she could lose both. So, therefore, probability she loses at least one game. Well, it's going to be both of these. It's if she loses one of them or both of them. So the probability she loses one or both, which we worked out here, it's going to be 41/72 or the second one. So add 21/72. And then add them as so 62/72. And you can leave it as that. They don't expect you can simplify it, but it should be fine. It didn't say to simplify your answer, so that should be fine. Okay, cool. Yeah, the mark scheme allows that as well in that form. Okay, all direct proportion again. Yeah, the direct proportion that comes to every single paper I've looked at now that I've done. Every single non-calculated paper, this has come up. So you know what? Really do revise direct proportion and inverse proportion. This will come up. Okay. Y is directly proportional to X. So I'm going to explain this again. So you can simplify this. So a lot of people often tend to overcomplicate it. They use this weird symbol here, which means proportional to, and do all sorts of weird stuff. All this means, if y is directly proportional to x directly, this means y has to equal k of x for some constant k. Okay, so k is a constant. Sometimes called constant proportionality because it's a constant linked proportion. Okay, that's all this means. So if you see one thing's directly proportional to another, you just write it like this. That's all. That is all. The reason for this is this looks like the graph y is x, right? If you look at it, it looks like a straight line. And it is, because what's happening here is if you increased x here, the x-axis, y increases as well. And likewise, if you decrease x down here, y goes down as well. So it's almost like the scatter graph relationship question. If one variable increases, the other has to increase with it, and that's all it is. Direct proportion. That's how they're both proportional, which means if one goes up, the other goes up. Likewise, if one goes down, the other goes down. You may also see inverse proportion, and that is when it looks like y k over x, and that looks like the reciprocal graph 1 over x here, and the other, and it flips. So as x increases, y decreases. So as one goes up, one variable, the other goes down. So it goes the opposite way. So it's inverse, right? Inversely proportional. Well, but as you see, if y goes up here, x has to go down, has to decrease. So that's what proportional means. So just remember those two equations here. Y is kx if it's directly proportional, or k over x if it's inversely. But here we're doing direct proportion, so you have to write down. It looks like it's y is kx, constant. Anyway, with that out of the way, y is 24 when x is 1.5. Work out value y. Okay, so simply you need to find k. So they give you these values for a reason. So y is 24, x is 1.5. It's a bog standard direct proportion question. If you practice this, it should be a doddle. But if you substitute this into this equation here, it'll always be the same equation with direct proportion every single time. You get 24 is k times 1.5. So now we want to find k. So then k is 24 divided by 1.5. If you're a bit unstuck on this, dividing a decimal, you can write it as a fraction. 24 divided, well, 1.5 you should recognise is 3 over 2. Divide by 3 over 2, that's the same as saying 24 times KFC, 2 over 3, flip the fraction times. Well, 24 times 2 is going to be 48, and then that's going to be 48 over 3. Can you simplify that? Yes, you can, because 48 goes into 3. 40. Obviously, writing out the box here. Make sure in the exam you write in the box. But yeah, I'm forced to write a bit large, obviously to make sure people can see, but also because I'm awkward with writing on the pen. Also, apologies for bad handwriting. I'm still getting used to this writing on the pen, on the digital pen anyway. But anyway, 48 over 3 divided by that. That does actually go in. A quick way you can check if something divides by 3. Add the digits together. 4 plus 8 is 12. If this is divisible by 3, then so is 48, the number itself. Okay, so 30 is 10, 33, 36, 39, 42, 45, 48. So that would be 16. So there's 16 times 3. Yeah, it's 48. So k is 16. So therefore, y back in this equation here is now 16x. So now when x is 5, y is 16 times 5, which should be uh, do, 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 80, I believe, right? Yeah, so y would be 80. Cool. Okay, so now on question 14. Right, a 16th in the form 4 to the n. So there's a clue here. We can write this in terms of 4. Well, actually, you should recognise here that 16 is 4 squared. That will have, so let's write that down, is 1 over 4 squared. Now, actually, you should recognise this is now the reciprocal. So that's going to be 4 squared to the minus 1. And actually, if you remember the other third law, index law we did last time, if you have it a power in a bracket like this, we could just times the powers together. So that's going to be 4 to the minus 2. 2 times minus 1 is minus 2. Okay. Okay, I'm going to do this question and we're going to take a little break. Okay, so part B then. So work out 8 to the 5 over 3 minus 9. Okay, so with index questions like this, do it bit. I'm going to keep reiterating this, but do it bit by bit. So work out the first term. We can probably simplify it a little bit. What's this as a number? Well, this is the same as saying cube root of 8. So we deal with the third bit first, times 5. And so what's cube root of 8? Well, actually, that goes nicely to 2. So 2 to the 5 is 2 times 2 times 2 times 2 times 2, if you don't recognise that already. 1, 2, 3, 4, 5, 2, 4, 8, 16, 32. And likewise, 9, 3 over 2. That's going to be just the square root of 9 because it's only over 2 cubed. Well, root 9 is 2 cubed. 3 cubed, sorry. Wow. 3 squared. I've got my numbers right. I've got it. No, it's 3 cubed. Yeah, it's 3 cubed. I don't know why. I got bamboozled. 3 cubed, not 2. 3, obviously. Don't know where I got 2 from. Anyway, 3 cubed. It's because I've got all the 2's here. That's why I'm getting it confused. 3 cubed. Square root of 9 is 3. So that's 3 times 3 times 3, obviously, which is going to be 27. 3 times 3, 9 times 3 is 27. Cool. So now, it's literally, what this means is if we did 8, 5 over 3 minus 9, 3 over 2, well, that's this. 32 minus 27. Wow, that's very easy, right? That should be 5. And there's nothing more we can do. That should just be your answer. 5. Okay, I'm going to leave that there. I'm going to need to take a break for a little bit. But if you want to look at this question, there we are. But I am going to be back in a little while. Think this is a hydration break or whatever. As a break, it is good to have breaks in revision or whatnot. But I will be back. I'll be back in a second. Thank you. Okay. Apologies, I am back. Hopefully, use that time to go over this. Although this isn't a bad question, though, to be fair, but let's put this up. So, this is straight lines. We got given two different equations, and we are given one is perpendicular to the other. So, what does it mean when two lines are perpendicular? Well, you should remember that this means gradients are negative reciprocal. I really, really do apologise. Uh, right, calamity going on over here. Um, I ordered shopping and it obviously came, so I had to put all that away in case it defrosted and everything. Doesn't help it's boiling today as well. Uh, but yeah, I do apologise. I'll try and see. Obviously the stream and Twitch. I don't think you can cut it down, but if I upload it on YouTube, I'll see if I can trim this part out. This is what? How long been gone for? Like 40 minutes. Um, but yeah, I really do apologise, but I am back now and should remain here to do the rest of the paper. Okay, I'm gonna I'll reiterate this question again. So we are given two equations of lines, two different ones, and we are given one's perpendicular to the other and find the constant. Okay, so what I said before, what does it mean if two lines are perpendicular? Well, they meet at right angles. And actually, what this means for lines is that their gradients are negative reciprocals of each other, which you need to know. So what this means is, what's the gradient of L1? Well, if we have the line y is mx plus c, the m is the gradient here, okay? So here, y is 2x minus 5. Well, the 2 is going to be the gradient, isn't it? So the gradient's 2. What this means is, therefore, L2, the gradient has to be minus a half. So what you do is take the reciprocal, a half, and minus it. You can check you've done it right because if you times the gradients together, you should always get minus 1, which is what you get here. So this means that they are perpendicular. Therefore, the equation of L2, we are given it here. So 6y plus kx minus 12 equals 0. To make sure we can see the gradient, let's put it in mx plus c form. So first of all, y has to be on its own. So 6y is minus kx plus 12. So then y is minus k over 6 divided by 6 plus 12 over 6, which is 2. Okay, so now we're in mx plus c form, it matches. So therefore, minus k over 6 has to be m, but the gradient m is minus a half. So we can divide by minus 1, get rid of the negatives. So k over 6 is just a half. Then you can times across and multiply. So 2k has to be 6 times 1, which is just 6. So k is simply 3 if you divide by 2. That is the answer here. Okay. Okay. Took like an hour for that question, although I wasn't here for like 55 minutes of it. I do apologise again though. Okay. Boy oh boy. Okay. So it says here's a sphere. So 3/8 of the surface area is 75 pi. Find the diameter. Oh, well, this is great news because we're given the formula of surface area. So this should be light work here, no? Surface area is 4 pi r squared. That's all of it, right? That's 100% of it. That's 8 out of 8, right? So it tells us 3/8 is 75 pi. So 3/8 of 4 pi r squared. So 3/8 of the surface area is 75 pi. Well, just let's work with this. So 3/8. Well, notice the 4 and the 8 cancel. Well, 4 cancels with the 8 because 4 goes into 8 twice. So you're left with 3. Well, you could just do 3 times 4, which is 12 over 8 pi r squared. Well, 12 over 8 simplifies down to 4/3. No, it doesn't stop. No, no, no. It's no, 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 no. It is 3/2, isn't it? 4 goes into both of them. Pi r squared. Make sure you keep checking. What I like to do is every time I write something down, I like to check and think a bit about jumping from one step to the next and making sure it's all right. Okay, so it's kind of like checking my work as we go along. So see here, spotted arithmetic error. So make sure to correct that. So that's what I like to do. Okay, so 3/2 pi r squared. Remember, is 75 pi. Well, we can cancel the pi. So we're going to solve for what's the diameter? But we know the radius. You should know that diameter is 2 times radius or 2 times r. So if we find r, we can find the diameter. Cool. So the pi's cancel. 3/2. Oh, that's a bit messy. 3/2 r squared is 75. Then, if you want to get r squared, times by 2/3. Because bear in mind, if you 2 times 3 times 3/2, it gives you 1. They cancel each other out. So you're just left with r squared. Okay, great. So 2/3 times 75. Well, what is that? Well, 2 times 75 is 150 over 3. Um, well, it's not really going to simplify, is it? Because, 150, well, 3, does 150 go into 3? Actually, it does, it turns out. Yes, it does. I was going to say it might not simplify because obviously there's a square root third here. But it does, because you can check this, remember, because I said earlier, if you want to check something divided by 3, add the digits. So 150 is 1 plus 5 plus 0, which is 6. And 6 is divisible by 3, so the 150 has to be. So how do we check that? Okay, well, what would it be? So 40, 80, 120. No, let's try 50, 50, right? 50. There we are. 150 of 3 is 50. Don't know why it's spelled earlier. It should have been, I don't know. So that means R has to be root 50. Okay. Now, actually, we can simplify this, can't we? You should know the third rule. Root AB can be said root 8 times root B. Now, 50 we can write as root 25 times 2, which is root 25 using this times root 2. Now, root 25 is simply 5. Root 2. Root 5 squared gives us 25. Lovely jubbly. So that's the radius. So therefore, the diameter, obviously make sure, use extra paper if you do need to go off the box. But obviously, I'm not in an exam, but if you need more paper, that's what you do. But anyway, make sure your writings are in the box, in the real thing. But anyway, so the diameter then, well, it's 2 times r, as we just said. But we know r is 5 root 2. So it's going to be 2 times 5 root 2. So 2 times 5 times root 2, that's 10. Lots of root 2, isn't it? So that is going to be the answer. And look, it's in this form here. A root b, but a is 10 and b is 2. Okay, and it says b is a prime number as well. Well, 2 is a prime number, so that probably is going to be right. Okay, I believe in myself there. Okay. Question 17. Make X the subject of this formula. So again, subject of the formula. It's fairly common question. Well, yeah, well, it's a common question, but This is this should be quite, if you practice repeat subject formula, this shouldn't be too bad. So the whole idea is we need to get x in terms of y, so x on its own. But obviously there's a bunch of x's here and y is on its own. Okay, so when you're dealing with a fraction, the best thing to do is to times across. So y lots of 5x plus 3. It's going to be 4, 2x minus 7. I think the best way then is to just expand the bracket. 8x. 4 times 2x is 8x. 4 times minus 7 is going to be minus 28. Okay, and expand this as well. So 5xy plus 3y just times by y. And then, so we want x, so let's put x's on the one side. So let's say 5xy minus 8x is minus 3y minus 28. Cool. Right, and then factorize x. So the whole idea, right, is to somehow with these subject formula questions get all the x terms on the same side. But obviously it's on the same side here, but it's a fraction. So the idea is to remove the fraction and then get x on the same side. Those are the two key bits. Those are the two key strategies you need to aim for when rearranging. Put x terms on the same side. So those are the two things you need to do. Once you do those two things, it should follow. But anyway, what you got on the same side, you should then spot we can factorize to get x on its own. So 5y minus 8 is going to be the same. So minus 3y minus 28. Yeah, then you could just divide. So minus 3y minus 28 over 5y minus 8. Cool. Okay, we can leave it as that. You could, if you want to simplify a little bit more, you could, you could take out the minus, or you could say by doing that, 3y plus 28. If you times by minus 1 over minus 1, 3y plus 28 over 8 minus 5y. So flip the signs essentially. But it doesn't matter. But yeah, for 4 marks, not too bad for 4 marks actually. Yeah, if you know rearranging subject and formula, this is quite a standard example. But yeah, question 18. I did hear a lot about this question when it did come out. I heard a lot of people struggle with a carrot and tomato question, so I imagine this is it. So let's have a look at it. Okay, 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480p. Cost of 1 kilograms to cost of 1 kilogram tomatoes is a ratio. Okay, work out. So it just looks like a simultaneous equation, really, just in the disguise. So work out the cost of 1 kilogram and 1 kilogram tomato. Well, again, exactly like I said before. Um, use variables. Use variables to represent unknowns. So we don't know the cost of 1 kilogram of carrot. So let's see equal cost of 1 kilogram of carrots. And likewise, let T denote the cost of 1 kilogram of tomatoes. Actually, let's have a look at this first bit. We are given 7 kilograms of carrots and 5 kilograms is 480p. And the answer's in pence as well, so just leave it in p. Don't convert to pounds. But yeah, but anyway. So, 7 kilograms, well, that's 7 lots of 1, isn't it? So 7 lots of C is going to give us 7 kilograms of carrots. Well, the cost of 7 kilograms of carrots, right? And 5 kilograms of tomatoes is going to be 5t. 5 lots of the cost of 5 kilograms of tomatoes, 5 lots of 1, right? And it's telling us that's 480p or just 480. That's the equation here. But we also we need another equation, right? If we're going to have simultaneous equations, we are given the cost of 1 kilogram of carrots to 1 kilogram of tomatoes is 5/9. So that's telling us that also that the ratio C to T, because the cost of 1 kilogram of carrots to C, and the cost of 1 kilogram of tomatoes is literally T, is 5/9. Now you could. I'm going to. Oh, my laptop needs a charger. Now, if you're really comfortable with fractions, you can just jump right into saying that C is going to be 5/9 T. That's what this means. But I'm going to show you how you can get that in a bit more of a formal way. If you're a bit unsure about fractions, I'm going to do some a bit rough work in here. So we are given that C to T is 5/9. What we want to show here, we want expression for C in terms of T, and we want to show this. I'm going to show you how to get to this. So, if you're ever unsure, when you have two ratios equaling each other, usually you're going to want to equate them, right? Like this. How do we do this? So, when what the aim of this, when you have two ratios the same, if you want to compare them, you have to make sure there's a common number in both of them. So, the best strategy that always works every single time is to put both of these ratios in the form 1 to n. N's just any number. The way you could do this is just divide by the first number on each one. So this one, divide by C. Well, C over C is just going to be 1. And T over C is T over, T over C, T divided by C. And this is going to be equal to, now do the same for this. Divide by 5. Divide by 5 as well. We're just simplifying the ratio. So 5 over divided by 5 is 1 again. And 9 over 5 is, 9 over 5. Okay, hopefully you spot why we can do this. It's just making ratios equivalent. So if any ratio, for example 2 to 4, you can simplify it by dividing by the same number. You are allowed to do that. It's equivalent. It's exactly the same as simplifying a fraction. So if we add 2 over 4, we can simplify that to a half. That's exactly what we're kind of doing here. It's exactly the same principle. We can do that. And that's what we're doing here. Hopefully you can spot why we can do that. Now, I said, now these are exactly equal because they're both in the form 1 to n. If this is 1 to T over C to what, they're both 1, so that means they have to be exactly the same. They're not equivalent, they are exactly the same. Which means T over C has to be 9 over 5, the second number. The first number has to be the same, 1 equals 1, and T over C has to equal the second number, 9 over 5. And now we just get to this. So, and now we could just cross multiply using the usual algebra. So that means 5T has to be 9C. And if we want C, well then divide by 9, like usual, with normal equations. So then 5 over 9T equals C. And that is what we've got here. That is how, if you are, that is how you jump from here to here. Okay. Obviously people comfortable with fraction ratios. You should be able to jump to that immediately. But if you're not comfortable, use this approach. Simplify the ratios to get a common number, right? A common term. So here, always make sure 1 is on both of them. Then you can easily compare them. And then you get to this, okay? This works for every single question, any ratio where the two ratios are equal. Anytime two ratios are equal, you can always do this approach. Always. Even if it's algebra, say if you have like x to x squared or something is 2 to 3 or whatever, you can, with algebra, you can still divide and get 1 You can do it with anything. This is why this approach is really good. Um, because it helps with harder examples as well. So if it helps with this helps with me anyway. So if you're unsure, that's how that. Oh God, that's the approach here. But anyway, if you're more comfortable with ratios, you should be able to jump right to this. Okay, so we've got two equations now, haven't we? Equation one, equation two. We can now substitute c into here. So sub 2 into 1. So 7 lots of 5 over 9t plus 5t is 480. Well, 7 times 5 is going to be 35 over 9t plus 5t is 480. And now we collect like terms. They don't give you a lot of room here. Oh God. Okay, well, 35 over 9 plus 5 over 9. Again, if it added two bits, this is also a fraction. It's 5 over 1, really. Uh, so we have to times by 9, both sides, to make the denominators the same. 5 times 9 is 45, and add them, and you get 80 over 9. Cool. So that means 80 over 9t is 480, which means t is 480 times, well, 9 over 80, right? If we want to get rid of this fraction, times by the reciprocal, 9 over 80. Well, 480 times 9 over 80. Well, does the 80 cancel with this? Let's have a look. 80, 160, 240, 320, 400, 480. No, yeah. So 80 does go into 480. Nice. And it 1, 2, 3, 4, 5, 6 times. So it's going to be, this will cancel this. I believe also 6 times 9, which would be 54. Right. So that means T is 480 times 9 over 80, which is going to be 54. 54. So that's remember, tomatoes, the cost of 1 kilogram of tomatoes, which is T. Well, we just saw T is 54p. Okay. Oh God. If I was in the exam, I'd ask for extra paper here. Sorry, it is a bit of a mess, though. They don't give you a lot of work in here. Okay, so found T. Substitute that into here. So we know that C then is 5 over 9 times 54. And actually, 9 goes into 54 6 times, doesn't it? We just worked that out. So it's 5 times 6, which is 30. And that is your answer to this question. Cool. Yeah, I did hear a lot of problems with this question. I think the hardest part of this question, like I said, people just aren't comfortable with algebra and using letters to represent unknowns. I think once you use this line, like let's C equals this and T equals this, it becomes a fairly standard simultaneous equations question. Well, it's a bit different, I guess, but this is you've got two equations, two unknown. You substitute one into the other, and it's the same sort of process. I think the hardest part is this initial step of like, oh God, there's so much going on. But this is what we want. This is what's unknown. And it's talking about cost here as well. So let so use just if you don't know something, use a variable, okay, and then use this where variable. Use the information to convert this into an equation or something, like we've done here, okay. But I think once you get past that hurdle, really look at it if you're stuck. and think, oh, why have I done this? And hopefully then it makes sense, and then the question follows from that. I think it's not horrendous, but I can see why people struggle. But like I said, if anyone is struggling or stuck on that, just shout, okay? I'll try and help if I can. Okay. Okay. In menu, restaurant starters, main courses, and desserts. 5 starters, 12 main courses, and X desserts. 420 ways of choosing one starter, one main course, and one dessert. So, I did cover this last time as well. There was another counting question, a choice question. In GCSE, you really, if we want to work combinations or something, you times them together. So the reason why this works is, uh, let's say, let's have three different lists, right? We can choose from the starter, main course, and the dessert. One, two, three, four, five. There are 5 starters. Uh, let's make this a bit larger. There were 12 main courses and there were X desserts. So there's going to be some amount of desserts, right? We don't know how many desserts are in this list, right? Desserts, main, and starters. Okay, suck my yes. God. So the way this works is, say if we for each starter we can pick then 12 mains and then another amount of desserts. So there are if we have the first starter, there are 12 choices we can make here. And then say if we then had picked the main, um, and then I'll continue this on, right? I'm not going to get too messy, but you get the idea. We can choose any main after this. If we pick starter number one, we can pick any of the 12 mains, right? We have free choice there. But then, if say if we pick the first starter and then the first main, well, we can still pick any of the desserts. We just don't know how many there are. So, for the first choice, there will be there's 12 choices we can make for in the mains. So, say if we had starter one, pick starter one. There were 12 choices we can make here, and there are X choices we can make because there are X items from the dessert list. So there are X choices we can make here, so a further X. Um, And the reason is every times, well, we have starter one. Main, if we pick the first main, there are X choices there. If we have two, then we can pick X again. So, so there were 12 options. So notice we're adding for the first main, there are X choices. Then if we pick the next second main, there are another X. Third, then we can pick X desserts again. There are X choices. X choices and it goes on 12 times, right? For each main, we can then pick an X choices from the desserts. So this is where 12 times X is, because this is the same as 12 lots of X, right? So this is where the timing is coming from. And this goes back to the starter. There are 12 choices for mains, okay? No, yes, after this. So, and because there's 5 of them, for each starter, we can pick 12, and there's 5 of them. So the amount of choices we can make is 5. So for any starter, we can pick 5 of them. And then there are 12 mains that we can pick. So we times them. And then there are X desserts we can pick. Okay. And that has to equal 420. So how many choices can we make in total? 420. Okay. Hopefully it made some sort of sense. But the idea is we split all our choices into different lists. And then say, well, for each choice here, we could pick all the options here. So that's 12. And then another 12, and then another 12, and then another 12, and then another 12. There's 5 lots of 12 choices we can make, 5 times 12. And then from that 12, we can then pick X each time and X choice. So we times by X. So this is where this comes from. It's counting, right? So we just have to solve for x. Right, to find x. Right, 5 times 12 is going to be 1, 2, 3, 4, 60, right? 60x is 420. That means x is 420 over 60. But how many 6's going to 420? 420 divided by 60. 1, 7, right? So x has to be 7. Cool. Okay, functions. Again, functions came up in the other past paper, so functions keeps coming up. Chances are functions are going to come up on this paper too. Anyway, so G inverse of 1. They asked to find the inverse again in the other paper. So, with inversing, on the basic level, all you need to do is say if y is g of x, so y would have to be root x plus 2 over 5, which is g of x. You basically want to switch the x and the y position, so x has to be in terms of y. The whole idea is, with our function, say here, the way functions are inverted is actually geometric. They're reflected in the line y is x, okay? That if that's g of x, it won't be, but say if it was for any general function, the inverse is what you get when you reflect it. So, and the reason why the x and the y switch place is because look at this. Say if this point is on g of x, reflect it on the line, it's here. Say if there's a point here on the y-axis, reflect that, it'll go on the x-axis. So notice how it flips the y now becomes the x. And that's what's happening here. The y and the x coordinate, well, they flip. Again, so that's all that's happening. So the geometry and the reason that's how inverse functions are formed is by reflecting it. You don't need to know this. Well, if you know it's at A level, but for GC you don't. But this is the reasoning behind it. Because the positions of x, y, they flip to yx. So that is why here the method is you want to switch the positions of x and y. So you rearrange for x in terms of y. Which actually reminds me, actually very, very similar to the rearranging question we did up here. Well, x is now in terms of y. That's exactly the same process we're doing here. Which makes me surprised actually, it's the same sort of question that comes up twice. But anyway, that's what we do. So rearrange again. Exactly the same process as we did before. Get rid of the fraction. So you times by 5. So 5y is root x plus 2. Get x on its own. So 5y minus 2 is root x. So therefore x, well, if we get rid of the square root, you're going to have to square it. Root x squared, obviously, it's going to just be x. And that is going to be 5y minus 2 squared. Now, they did not ask to simplify it, so you can leave it like this, but I think for part B it will help. Actually, no, but it's best to do it anyway. You don't need to, but it's best to. Let's practice. So 5y minus 2, 5y minus 2. That's what squared means. You times it by itself, which is what we're doing here. Now, expand it out. 25y squared. 5y times 5y, 25. 5y minus 2 is minus 10y. Minus 2 times minus 5y is minus 10y again. Minus 2 times minus 2 is plus 4. And so that simplifies to 25y squared minus 20y plus 4. Okay. But if he, it might be a good idea if you want to just leave it like this. It doesn't say to simplify, so you can leave it there. However, in order so you don't if you think you're going to mess up the expansion, no need, just do that. And yeah, that's that question done. I'm gonna need to take another break and gone. Sorry, apologies. Be back in a second. Have a look at part B then. See how you'd approach that. Apologies, I am back again. I really, really do apologise for these breaks. But stuff comes up, you know. Okay, so I did part A, and hopefully you had a look at part B. So, it says solve this. Now, this is again a standard functions question. With this, the hardest thing with this is to understand the notations. What does this mean? Well, uh, what this means is it's saying g f of x like this is g of f of x. So you're inputting f of x into g where x is. This does not mean g of x times f of x. And this is why I don't like the notation, because if you look at it elsewhere, uh, there is other ways of expressing composite function. This is a composite function where you input one function into another. Um, but this is not a product. Okay, I know you might be tempted to, but if you look here, g has no brackets here, so that means we have to input f of x. We're not timesing. If it was times, then it would look like g of x, f of x, right? Where you have a bracket for the x's on both of them, so the two, okay. But because there's no g of x, f of x, it's just g of f of x. That means we're inputting f of x into g. Okay. So we need to input f of x into g. So f of x is 3x plus 4. And so we need to input this in g in place of x. So instead of root x, it's root 3x plus 4 plus 2 over 5. And we're told that this is equal to 3. So we need to solve this for x. So again, you're kind of like rearranging. So get rid of the fraction. So root x, root 3x plus 4 plus 2 has to equal 5 times 3, which is 15. Make the root on its own. 3x plus 4 is 15 minus 2, which is 13. And then square both sides to get rid of the square root. So 3x plus 4, not 14, 4 is 13 squared, which is 169. If you're struggling with that, just do a quick long multiplication bit over here. 3 times 9, 3 times 1 is 3, add a 0, 1 times 3 is 3, 1 to 1, add them, 9, 6, 1. Cool. That's if you're stuck to work out 13 squared, okay? Don't be afraid to use mental methods like that if you're struggling. But anyway, so 3x plus 4 is 169. 3x on its own minus 4, 165. So that means x is 165 over 3. And again, that has to be this has to be divisible by 3 because the digits 1 plus 6 plus 5, which equals 12, is divisible by 3. Okay, so what would that be? 50? No, 150. Has to be a bit more than that. 55? Yes, because 50 times 3 is 150, 5 times 3 is 15, 150 plus 15 is 165. So that's our value here, 55. Again, if you're a bit stuck with that, use a quick bus stop method. 165 and then work that out, okay? But yeah, so that's the approach. It's a standard functions question. They like to ask you to either invert something or find a composite function. That's all you expected to do. It's the same stuff. If you practice these functions questions, these are very, very typical. Okay, and again, functions have come up on multiple paper ones now, so I would expect this to come up on your paper one paper. I really would. It'd be wise to practice it. Okay, but you should be practicing everything here. Okay, you should practice every topic really, but that comes up a lot. As for circle theorems as well. So here we are. ABD are points on the centre O. And we're given the tangent here and work at the side of angle ADC. So again with circle theorems, I think it's good to list them. So you have circumference, no, centre is double the circumference. Is twice angle circumference, twice the circumference. Obviously, it's not correct fully, but I'm just paraphrasing a little bit, just because it's a mental note, okay? But the angle at the center is twice the angle of circumference. That's one of them. We have radius perpendicular to tangent. We have alternate segment theorem. And we have angle in a cyclic or cyclic quadrilateral are, I believe, opposite. I believe that's a circle theorem. Uh, uh, yeah, they are opposite, so they add up to 180. But also, you should know the other one is angles in a semicircle, or the angle, I should say, because one of them is right angle or 90 degrees. Okay, so those are the five circle theorems that you're going to want to reference from with these circle theorems. You don't have to write them down, but you do have to remember them and make a mental note at least. Okay, so what I like to do is I like to see what we're given and see what we can use first. And as a rule of thumb, I do like to use alternate segment last. This does look like an alternate segment, but let's see what else we can do because we are told it's a tangent as well. So actually, yeah, that's a good point. So radius here, this is the radius, this is the tangent. They are perpendicular, so this is going to be 90, as is this side here. Cool. So, but we know that, but we can't do it without that yet. Alternate segment, we try and leave until it's the only thing we can use. Cyclic quadrilateral. We don't really have a quadrilateral at the moment. We have angle in a semicircle. A semicircle would be if you have radiuses connected like this, a diameter almost, a diameter you have, right? But we don't have that here. But what we do have is an angle in the center, and we can invoke this first theorem. So if you have a look here, center at the angle at the center is twice the angle of circumference. That's going to reference this angle here, because if you notice here, the idea is if we have an angle, this is the center, right? An angle. If we have two radius, and they are and they hit the a really bad circle, but if they both hit the circumference, if they then further hit another point on the circumference and they meet together, uh, like this, like have a look here. I don't need to. Let's have a look here. So here, right, we have a center. See here, we have two radius, OB and OD, here and here, but they both meet again at A. Oh God, what am I doing now? For God's sake. And shores again. Oh God. OB. But this meets at A here. This also meets at A here as well. Right, notice that? So if you have two radius and they go on to then intersect together at the circumference, that angle here and that angle here, this is double the angle here. So this is the angle at the circumference and this is the angle at the center. And they kind of mirror each other in a way as well. But that's the idea of the circle theorem is if you have two radii, two lots of a radius, and they going off to the center, and they both meet at another point on the circumference, which is A, the angle that is formed is half the angle, right? So that's probably going to be our first step, right? And half of 64 is going to be 32, right? So let's write that down. So, and then we can see what we can do from there. So angle, and this is notation for angle, by the way. What's this? BAD. That has to be 32 because angle at circumference is half the angle at center. Cool. So what can we do now? Well, notice that this is a triangle, AB, and then this point here, X. I'm going to call it X, right? Or or you could call it F, I guess, but call it X. It could be anything you want. This is a triangle ABX, right? And actually, we know what this side is going to be as well. So angle uh, AXB is going to be, wow, 180 minus 32 minus 51, which is what? Well, 32 minus 50, plus 50, 51 is 73. So then 180 minus 73 is going to be 107, right? So this is 107. 107 degrees. The reasoning is angles in a triangle add up to 108 degrees. Now, you don't actually have to write this bit. The only thing it wants you to do is write down any circle theorems you use. This is not a circle theorem, so you could just say it's 107. But yeah, I guess for the sake purpose of revision, I write it down anyway. So that's AXB. X is like the mid, the intersection point here. Now notice that this is vertically opposite to this angle here. Because they are vertically opposite. So what angle we have here? Look, this is what the situation is. This angle here we said 107. So this angle here has to be 107. They're vertically opposite. So vertically opposite angles. So if you have a cross, essentially, two lines crossing together, two angles like this vertically opposite, they have to be the same. So therefore, angle DXO is also 107, as vertically opposite angles are equal. And actually, you can see by this point, we are getting a lot of information out, right? So we're getting somewhere. So, and again, triangle. So it asks us to work out angle ADC. We'll have a look at that in a minute. So ADC, okay. Well, we know this angle here, so let's work out every information we know. So angle, this. So again, this is going to be 180. This angle here, triangle DOX. So the angle here, so angle, what would it be? ODX. Well, that's going to be 180 minus 64 minus the x, the one we worked out, 107. That's going to be, well, 64 plus 107 is 171. So angle ODX has to be 9, right? 180 minus 171 has to be 9. As angles in a triangle, again, sum to 180. Okay, we're nearly there. So it says the angle ADC. So actually, what it's this angle here. Let me try and make it clearer. Is this angle here, ADC? But obviously, there's a tangent going on here. But we know if we have a look, we worked out this angle. This angle was what we just worked out, 7 degrees, right? No, 9 degrees, wasn't it? That was 9 degrees. But this is the radius, right? And the radius here, I know it's not the clearest, I do apologise. This is the radius. So this is going to be 90. This whole angle here is going to be 90 because they're perpendicular. This we've seen was 9. So we want to work out this missing angle here. So actually, it's just going to be 9 take away 9, isn't it? So therefore, angle ADC is going to be 90 minus 9. It's going to be 81. And this is because as radius and the tangent are perpendicular. And that is going to be your answer. It has to work at ADC. And that should be your answer. A lot of work for 4 marks. They're probably, again, you might be able to use alternate segment. There is probably a more efficient way, but I'm sure at least with probably other people, but I'm not the best at circle theorems. I don't like them. Probably with a lot of people, but this I think is the worst one. Alternate segment. The other theorems make sense. Most, in my opinion, it's just this particular one with segments I don't like. Sometimes you have to use it sometimes, but I use it last. It's a rule of thumb to use it last and only use it when you have to. And we didn't have to use it in this instance, but there's a bit more working out. But like I said, you don't have to. The only ones you need to write down the reasons are the circle theorems here. So the radius and tangent and the angle, the circumference, and the center. These other ones you don't need. You can just write the numbers, okay, and show you working, obviously. But these are not circle theorems, okay. But these two are the top and the bottom and the top. Okay, hopefully that makes sense there. I do apologize if not clear-ish. Uh, tried my best here. But hopefully it made some sort of sense. So again, this is going to be 90. That's 9. So that's has to be 81, and that's missing angle there. Okay, hopefully it makes sense. But yeah. Okay. Now on question 22. We have a 3D cuboid. AF is 6.8. Let's write that down here. FC is 13.6. Cool. Work out the size of the angle between FC and the plane ABFD. So plane, so AB, so it's just a fancy way of saying the surface. So ABCD, well, it's this face here, right? It's the bottom face. But it says the angle between FC, the line, and the plane. Well, if we draw the line FC, it's going to an angle between that and the plane. Uh, well, F is below A, and A. If you think about it here, oh God, what have I done here? I know this is hard to explain again. Like anything with geometry and visualization, it really is hard to explain. But if you uh, we're interested in this angle here, FC and the plane. So this angle theta between F and C. But the way you work out this triangle here, look here. So the length here, and then this is one here. This is a line, and that's a diagonal. That would be like the adjacent, and that's the opposite. It really is hard to explain 3D. The idea with 3D, right? The 3D triangles and angles like this. You basically just want to find 2D triangles to make. that is the idea here. It's just 2D triangles made out of 3D. But it is hard to explain. Okay, but it's told AF is 6.8 and SC is 13.6. So it does give you a clue actually of where to go because you know F to C and you know it's going to have to include A. So actually, that's a good bet. That's a good bet. And actually, this is the triangle that we have here. Okay. Yeah, it's only 2 marks, so that's the triangle we're working with. Not too shabby. Okay. So it says to work out the angle between FC and the plane. So between FC and the plane. Well, this is the plane, right? This whole bit, this line here, that's on the surface. It's on this one, right? This line here, A to C. So it's going to be between this on the base and here, FC. So this angle here. And actually, spot if this is the right angle. Um, yeah, if you visualize it anywhere, that would be a right angle. But yeah, how do I guess because if you rotate, say if you rotate, okay, I'm not, ignore me, I'm going to waffle a little bit, but if the visualize this is indeed a right angle and a right angle triangle, say if you rotated the C and onto D, say if we move this triangle so it hits D instead of C, well, then it would hit FA, then it would move to AD, right? And this would move from F to C to F to D. Now, obviously, FA and AD are clearly right angle, clearly right. So it's just about orientation, essentially. So that has to be a right angle. So then if we move the triangle, the edges around, your spot is a right angle. Anyway, so I'm just trying to explain the visualization behind it. I know some people are a bit uncomfortable. Uh, Obviously, if you don't understand me, I recommend watching other videos. That sounds bad. Oh God, don't listen to me. Uh, but for me, I don't know. I feel sorry for teachers that have to teach this. I don't know. But yeah, that's the strategy. Essentially, it's to spot 2D triangles to make. And I'm going to stop waffling now. Hopefully, you can spot this is just some simple trick. So you should know Sokotoa to find the angle. So what do we have? Well, this is the adjacent. This is the hypotenuse. And this is the opposite. Well, we know the hypotenuse and the opposite, so it's going to be SOH. So sine theta is opposite, which is 6.8, over the hypotenuse, which is 13.6. Now, what does this simplify to? If you know your trig ratios, there's actually a certain amount you can do. Let's check. Does 6.8 go to 13.6? Actually, it does. 6.8 times 2 is 13.6. So this is 1 over 2. So sine theta is a half. Now, you need to know the exact value, uh, which gives a half. To know this, there are certain angles you need to know, and I did go over this in like a non-calculate revision. I did go over it in another one, but I'll go over the method again. Instead of just going there memorizing the values, and it might be a bit off-putting, I like to do this finger method. It's really bad. Oh God, I'm sure it's slightly better one than that. Oh God, it's like I've never seen a finger before. Oh, what shape am I doing? I'm trying to draw a hand here. Hand with 5 fingers. Come on. Oh, that's terrible. What the hell? I'm definitely, obviously not an artist whatsoever. Oh God. Slight. It's as good as it's gonna get. Okay. So the aim of this, obviously, there's 5 fingers, 5 parts. You wanna start with 0, 30, 45, 60, and 90. Those are the degrees you need to know. And yeah, so the idea is with uh, with sine theta, it's the root of the finger over 2. What do I mean by root finger? Well, sine theta, you start from 0. You want to count how many fingers does it count? Do you get to a certain angle? But obviously, you're going inverting this time, so we need this sine theta to be half. If we compare, the 2 and the 2 are the same, so root finger has to be 1. So this tells us we need to move 1 finger, okay, to get to what root 1 or 1, if we use this method. So you start from 0, and then say if we did 1, that'd be root 1 over 2, which should be 1 over 2. That's 30. That's when we reach the 30-degree finger. So that's telling us the angle has to be 30 degrees. If we use the exact value. So you're kind of inverting it. So if we moved 1 finger, that would be root 1 over 2, which would then be a half. So it has to be 30 for sine theta to be a half. Okay. So that's obviously use the method you prefer. Some people like creating triangles. Some people just learn the values. I don't recommend that. I like this method. I've learned in my GCSE. I still remember it now. I don't need to calculate it to work out these values. I just remember it because of this hand method. I did go over the hand method in more detail in a separate video, non-revision video, non-calculated revision video. I did go over this if you'd be unsure. There are obviously other videos on YouTube. Obviously, whatever helps you the best. So, obviously, 2 marks. Some people are like, ignore it. You can do that for 2 marks if you don't want to bother with it. It's not the end of the world, but aim for perfection, right? Aim for as many marks as you can. That's the best strategy. And I don't think this is too bad. I really don't think learning this is too bad. Um, Once you do, it's pretty easy marks, really, in my opinion. But yeah, so that's the idea with that. I do understand this could be a bit of a tricky question, but that's how you approach it. Okay. But moving on from that, we got quite an interesting third question. Third rationalising question. So write this in the form. So clearly the third's on the bottom, so we're going to need to rationalise. And we can see this because the third is gone on the top and none on the bottom. So we're going to need to rationalise. The best thing to do here, there are 2 ways you can do this actually. You can first combine it as one fraction. But I think the best way, like I said with the other questions, split it up first. Do it bit by bit. So rationalise this fraction and then this one and then do something after. So 3 root 3 over 4 minus root 3. You're going to need to rationalise this. So the way to do this is to say 4 plus root 3 over 4 plus root 3. And then look what happens. 3 root 3 times 4 plus root 3 over 4 minus root 3, 4 plus root 3. And I'll show you why this works in a minute, but that's the method. Obviously, 3 times 4, that's 12 root 3 plus 3 root 3 times root 3. So remember, AB is root A times root B. Root 3 times root 3, so root 9, which would just be 3. Times 3, so that'd be 9. So let's go over that bit again. So you got 3 times root 3 times root 3. Now root 3 times root 3 is just 3. So that's 3 times 3 is 9. That's where that comes from. Okay. Just to be clear on that, hopefully it makes sense. A lot of root 3s going on here. And then we expand this. So 16, 4 times 4 is 16. 4 times root 3 is just 4 root 3. Minus root 3 times 4 minus 4 root 3. Can't draw 3. Oh my god. And then minus root 3 times root 3. Well, that's going to be 3 minus 3, right? and then simplify. So 12 root 3 plus 9. We can't do anything more there. But this we can. The 4 root 3 minus 4 root 3, they cancel the opposite. And then 16 minus 3 is 11. And that is rationalised. We can't do anything more with that. The reason why this works is, and what you want to set the opposite sign here. So notice 4 minus root 3, 4 plus root 3. Notice this we get 16 minus 3. Notice how this is the same as 4 squared minus root 3 squared. This is the difference of two squares. That is the aim here when you want to. That is the aim when you're rationalising the denominator like this. You want to make a difference of two squares, which means if we square this, we get rid of the square root. That is the idea behind this, okay? So if you create an opposite, so remember, a squared minus b squared is a minus b, a plus b. That's the difference of two squares. That's what's going on here. A is 4 and b is minus root 3. We times by a plus b, so 4 add root 3 to get a squared, which is 4 squared minus b squared, root 3 squared. This will always ensure we get rid of the third square root, okay? Because we're squaring it. A square root, we get the number, right? Just 3. That is the idea behind this method here. You want to make sure that you get a difference of two squares to ensure that the square root gets rid of. And you can see that because the root parts cancel, and they will cancel every single time. But yeah, that's the idea behind the method. But if you practice rationalizing a denominator, that's the process. That shouldn't be anything new, hopefully. So we did that fraction. Let's do this. 2 root 3 is a lot more simpler. So we could just times by root 3 over root 3, because obviously they will just give us 3 if we times them, over 2 root 3 times the top and times the bottom. Cool. So therefore, if we're subtracting this, 3 root 3 over 4 minus root 3 minus 2 over root 3, that is the same as 12 root 3 plus 9 over 11 minus 2 root 3 over 3. So now we're just subtracting fractions, right? But none of these is a common denominator, right? They're not the same, and the only way we can make them common is to times by the opposite. So 11 times 3 is 33, so it's going to have to be out of 33. I'm going to bring it over here actually. So make both of these fractions out of 33. So how do we get 33 here? Well, we're going to have to times top and bottom by 3. So 12 times 3 is going to be 36 root 3 plus 9 plus 3 is going to be 27 minus this. So how 3 to 30 we're going to times by 11. So note we times opposite. 11 times by the opposite denominator. So times the top and bottom by 11 here. 2 times 11 is going to be 22 root 3 over 33. And now we can simply subtract the top, right? Because they're the same denominator. So 36 root 3 plus 27 minus 22 root 3. Oh, hang on. Make that clearer. Minus all over 33. 36 root 3 minus 22 root 3. Well, that's just 14 root 3 plus 27 over 33. And yeah, it's in that form, right? A root 3 plus B over C. We cannot simplify that anymore, I don't believe. And it's in the form they wanted. So that is their final answer for 4 marks as well. So it looks a bit, I guess, a bit intimidating, but break it down. You should know how to rationalise a fraction. If you know that, you can do the question. Just rationalise it fraction by fraction, right? There's 2 there. You might not be used to seeing 2 different ones. Just do it bit by bit. And then you should also know how to subtract a fraction, right? Just apply your knowledge there. So once we rationalise both the fractions, we subtracted it here. And then we get and we got this subtraction. You should know how to subtract fractions as well. You must know the denominators must be the same. So you times by the common denominator, times this by 3 to get to 33, times that by 11, times the opposites, and you get this. And you should also know how to simplify thirds. So you should know 36 root 3 minus 22 root 3 is 14 root 3. All of that, shouldn't be new. You should know how to rationalize. You should know how to subtract fractions, and you should know how to simplify thirds. You just combine them together. But if you do it bit by bit, it should be you should be able to tackle it. Don't be too put off by it. But that's the approach. That is meant to be hard because this is the final question. So this is at the end of the paper. But now we're on the final question. Finally, it seems. But too far, I was away for like an hour. Anyway, the final question. And I do predict something like this comes up. They do love asking this with two lots of inequalities you have to solve. But all that means is you just solve them individually. Again, I'm repeating myself again. We have to solve two inequalities. Solve them bit by bit. Do it bit by bit. Solve one, then solve the other, and then see what happens after. And that's exactly what they're going to do here. So two quadratic inequalities. Solve the first one. And actually, it's already in a pretty nice form. Notice this is the difference of two squares. 2x minus 5 is less than 0, right? Hopefully you can spot that. If you don't know how to spot it, you can't. The idea is to find the critical roots, right? So the critical roots or critical values, I guess, are x is 5 over 2, so 2x minus 5 equals 0, or minus 5 over 2. Okay, hopefully you can spot that. And the idea is from the critical values, we can now sketch the quadratic. So minus 5 over 2 is going to be like over here, and 5 over 2 is going to be there. And obviously the y-intercept is going to be minus 25. It's going to be like all the way down there. So if you sketch the curve as so that's x and y. That's what the graph looks like. So with quadratic inequalities, always sketch the quadratic. This is why we want the critical values, because it tells us the intersection that helps us sketch the graph. Okay, so I've done that. That should be procedure, right? So what is this telling us? Well, if say this is y, the curve here is y. So y is 4x squared minus 25. It's saying y has to be strictly less than 0. This means y has to be below the x-axis, right? This is where y is negative. Y is less than 0. This bit here, okay? So it's below 0 between the critical points, right? The intersection. Minus 5 over 2 and 5 over 2. That is where the curve goes underneath. That's the region we're interested in when it's less than 0. Okay, hopefully that makes sense. And it has to be strictly less than 0. It equals 0 at these points, but it goes below 0 when it's over the points, right? It's in the middle. Okay, so it has to be a strict inequality there, and that's the solution, right? So you can see the area we're interested in is between the points. This is the solution here, and I'll highlight it here. Now I said split it up. So now, oh god, what am I doing here? Oh god, what's going on here? Stupid thing. I just have to slow scroll. I do apologise. Bloody computer. Okay, So now we solve the other inequality, right? So solve the other one. So 12 minus 5x minus 3x squared is less than 0. I don't like the negative here. I don't like solving quadratic with a negative x squared. So what we do is times by minus 1. So 3x squared plus 5x, flip the signs, minus 12. Now, when you times or divide by a negative, you have to reverse the sign. Okay, remember that. That's the only difference. You basically treat inequalities like an equation, but the only difference with an equation is when you divide by negative, you have to flip the sign. Everything else is the same. Okay, hopefully that makes sense there. Okay, so we want to solve this. There are, I would again, non-calculator, don't bother with quadratic formula. You could complete the square, perhaps. Again, it's not going to be nice because say if you have factor 3 out, x squared plus 5 over 3, then you have to it's going to be nasty fractions, right? Let's try. We might have to do that, but let's try. Factorization. So you should know how to factorize a quadratic with a big x squared coefficient like this. So the idea is, again, like we had to, at every single non-calculated paper, we had to factorize a quadratic like this, a hard quadratic, they call it, right? Where the coefficient is bigger than 1. So you should know the method behind this. Obviously, everyone might have their own one, but this is the one I go for. So what you want to do is consider times in the number minus 12, the constant, by the coefficient 3. So you should have minus 36. Now, we want a number that will times to give minus 36. So this is like the new constant, and add to give 5. What numbers are they? So 36, right? What are the factors? 36 and 1. 2 and 18. That won't give us 5. We can't find another way. What about 3? 3 goes into it. 3 and 12. No, there's no way. The difference is 9. 4 and 9. Actually, yes, we might have something there. 9, perhaps minus 4 gives us 5. We might have something there. Well, yeah. So 9 minus 4, right? If we add them, we get 5, and times we give minus 36. So that is our solution here. So you do 3x squared plus 9x minus 4x minus 12. So we split the 5x to plus 9x minus 4x. This is what this method is doing. It's giving us the right way to split up the 5x so we can factorize it. Why that works, I'm not going to go into here, but that's the method behind it. That's the idea. So, like I said, we have 4 terms. We can factorize each side. So, factorize this first part here. 3x squared plus 9x. Well, 3x is common. X plus 3. And minus 4 is common as well. Minus 4 of x plus 3. And actually, both terms are common here. So, x plus 3 is a common factor. Then 3x minus 4. Okay, so this now factorizes the x plus 3. 3x minus 4 less than 0. Cool. And you can see this nicer than completing the square with dealing with messy fractions. Cool. Okay, so again, exactly the same procedure. Sketch the graph. It's going to intersect at minus 12 here. The critical values, I'm going to just put the CV, critical values is going to be minus 3 and 4 over 3, right? If you solve 3x minus 4 equals 0, x is 4 divided by 3. Cool. So minus 3 is going to be all the way here, and 4 over 3 is going to be there. So the quadratic is going to look like that. That is what, if you sketch this quadratic here, if you plot the critical values, the x intersection here, and the y intercept is clearly going to be minus 12. That's what the graph's going to look like. And again, we want this to be less than 0, which is going to be strictly when y is below the x-axis, so here. And this will happen again when x is strictly between these critical values, right? So minus 3 is less than x, less than 4 over 3. So that is our other solution. That's most of it done. So I'm going to bring this together now. 5 over 2 to x 5 over 2 and minus 3 less than x to 4 over 3, right? That's the two solutions. So from the set of possible values for x, so no integers or anything like that, just x. So we need to make sure x satisfies both of them. The best way, so the way to do this is to look at the minimum for each. Which one's bigger, minus 5 over 2 or minus 3? But minus 5 over 2 is 2.5. So between x is minus 3 or minus 2 over 5, well, minus 2 over 5 is bigger, so that's going to be the lower bound for x. Because if x is less than minus 4, if x is bigger than minus 2.5, x also has to therefore be bigger than minus 3. So minus 5 over 2 is a stricter condition, if you will. It's a stricter inequality. So you pick like the biggest minimum and the lowest maximum. So x is less than 3 over 2 or 4 over 3. 3 over 2 is 1.5 and 4 over 3 is 1.33. Because the third is 0.33, so 4 over 3 is 4 lots of that, 1.33. So 1.3, 4 over 3 is less than 3 over 2. So that means x has to be to pick 4 over 3 here. Because if x is less than 4 over 3, that means by default x also has to be less than 3 over 2, because this is actually bigger than 4 over 3. The way, if you are struggling with that, is actually to oh, not this again. Oh, there we go. Nice. I'll draw it here actually on the blank page. If you are struggling with like let's write it here again. If you are struggling to kind of like get your head around that or visualize what to, the bounds and what to accept, what the inequalities are, sketch it on the number line. Sketch two solutions, inequalities on the number line. So x 5 over 2. Sketch on the number line here. So x here. Actually, you don't need this line either. You just need the x. So on the number line for x here, say this is 0. Well, minus 5 over 2, say here, that's going to be minus 2.5 or 5 over 2. 5 over 2 is going to be on the opposite side, 2.5. Actually, I'll make that concise, actually. Make that consistent, sorry, not concise. Waffling. Minus 5 over 2, or minus 2.5. Cool. So that's this one. So then if you plot the solution on the number, you do need to remember how to do this though anyway. On the number line, the inequality for x would look like this. Okay. Now minus 3, well we said minus 3 is below this, so minus 3 would be here. And 4 over 3 is... Wait, was it 3 over 2 or 5 over 2? Oh, it's 5 over 2. No, sorry, I did 3 over 2. No, 5. Oh. No, yeah, sorry. No, that's wrong then. No, it isn't wrong. It doesn't change. But 5 over 2 is 2.5. But that wouldn't change this, would it? 2.5 is still bigger than 1.3. Okay, but I got it wrong. I wrote it down wrong, but the answer's right. Okay, cool. So that's 2.5. 4 over 3, as we said, is 1.33, so that'd be like that. So if you just get the rough decimal of all of them, you can kind of picture them on the number line. So 4 over 3 be there. So our solution for x has to be where it falls on both the number lines, right? So here to here, right? X has to be between here. In order for x to be on both the lines. That's all it is. And so obviously xn has to be at this endpoint here, which is minus 5 over 2. Has to be strictly between that because it's not a field. It's so it has to be less than. And has to be between this endpoint here on this line, which is 4 over 3. So the upper limit is 4 over 3. The lower is minus 5 over 2. So that's how you can visualize it if you're a bit stuck. Just draw it on the number line and then see where they overlap. They're both on, and that's your solution. That's where the x should be here in this interval, where it's on all the lines, both of them. And you see here, minus 5 over 2, 4 over 3. That's what we got here at the end, and that should be the solution. That is your solution. Minus 5 over 2 between x between 4 over 3. Call it over 5 marks. Yeah, and that's how you do it. So don't freak out. You say, oh, there's 2 inequalities and all this. Oh, it's a bit different. Normally I'm only used to solving 1. Oh God, what do we do here? Break it down. Chill. Break it down. You actually probably get a lot of marks if you just solve them on their own. And you don't know what to do afterwards to combine. You don't know. That's fine. You probably still get 4 marks out of 5 if you know how to solve quadratic inequalities. In usual, you'll still get most of the marks if you freak out, but don't freak out. Just think about it and take your breath and do it bit by bit. Solve the first one, solve the other one, and then go from there. Okay. But that's the idea. They do love asking these questions where you have multiple inequalities and you have to combine them together. So when you do combine them, obviously, if you're proficient enough, think about how to combine them together like this. Or if you're stuck, write them all on the number line, and then see where the both are. So x has to be on both the lines. So you have to consider it like this. Yes. So hopefully that makes sense. I'm actually at the end of the paper now, unfortunately. But yeah, I'm gonna leave that. I'm gonna leave that there. But like the 2 points again I want to echo is A, again, take it bit by bit, work out what the question is, work out what topic the question is, and then work out what you know and what examples you've done on that topic, and go bit by bit. Yes, so for example, like with the rationalising the denominator question over here, um, you only use to maybe only rationalising a single fraction, but that's all you have to do. Rationalise the first fraction, do fraction the first one, then the second one, then subtract them. Do it like this, and that's all you have to do. That you've done that before in where you should have practiced rationalising. You can apply it here. It's exactly the same thing, just a bit different. So split it up, and then go from there. Don't try and try to do multiple things at once and jump too many things. Take it easy, go step by step, split it up if you need to. And then it should follow from there. That's the one message that I keep echoing. Like here as well. Instead of trying, oh, how can I just subtract them? God, there's nothing there. I can't do this. And you should know your index laws, right? Do them individually first. 8 5 over 3 is 32. 9 3 over 2 is 27. Well, then I can subtract these two numbers, can't I? And you get 5. That's your answer. Instead of just freaking out, oh God, how do I do? I can't. How do I subtract the indexes and all that? Oh, I've done this, but you do know how to simplify a single number like this. So just take it easy, step by step. Take it easy, and then it should follow from there, and it shouldn't be too bad. That is my main piece of advice. And the second advice is a lot of the questions and the topics keep coming up on these papers time and time again. Direct proportion and found come up on all 3 papers. I've tried for non-calculator. So, really practice these topics, practice exam papers, practice top questions. And you know what? A very, very, very similar question, or it will require the same knowledge on your paper, so you'd be better prepared if you try it. If I hate your bet, for example, if you try direct proportion, that will come up on your paper, pretty much guaranteed. And So if you practice all direct proportion, you're very good at it. You're going to pick up the marks for direct proportion on your paper because it's going to come up, and you're going to get practice for it. So yeah, that's my 2 points of a piece of advice. Practice past papers. Questions tend to come up. Topics come up time and time again. Two, split the question up bit by bit. Like this, don't freak out. Oh God, a pentagon. Oh, what's all this? Oh God, so many angles. Da, 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 da. Again, make this X, and then you know you're given this. So then it's a fourth X. Well, there's only one unknown. Well, then, what do I know about angles? Well, I know they all have to add up to 540. So then I've got an equation. I can find x. There we go. Lovely, lovely. Rather than, oh God, there's these missing angles here. What's his angle here? What's his angle here? Oh God. Oh God, what do I do with all these angles? There's so many angles. 5 angles. Oh God, I can't do it. Just take it easy. What don't you know? Well, you don't know this angle. Call it x, whatever. But you know this angle then because it tells you this. And then you can go from there. And you know stuff about all the. It's a pentagon, so you should know what these angles add up to, and then you can take it from there. So again, take it easy, go step by step, and then go from there. That is my main message. Hopefully that makes sense. This is the whole idea of this, is trying to demonstrate what the thought process is, how you should approach the paper and do the questions, or what you should be thinking, what you should be writing, and so on and so on. Hopefully this made sense. But as I say, if there are any questions, let me know. Obviously, you got a paper on Thursday. But yeah, that's it. I'm going to stop the waffling now. And I just want to say again, I do apologise. I took a lot of break today. I think stuff came up. But if you are on YouTube, I'll see if I can find a way to cut it down, to cut all that stuff out. But again, I do apologise about that if you're watching in real time. But yeah, let me just have a look at the chat. Oh hi, yeah, GCSE tomorrow. Biology, cool. Yeah, if I was you, I'd probably revise biology, not maths. But it's glad you're watching. I'm glad Year 11's watching. I'm surprised it's getting a reach, but I hope this helps. This will be on my YouTube as well. It'll be there permanently. And it'll be on my Twitch for 7 days as well. So obviously, for Thursday, it'll still be here if you want to go through it. I do recommend as well with these videos, or any videos, anyone going over past papers, not just me. There are many people out there. Do the paper, the questions yourself, especially the ones you struggle with. Do it and try it first, and then watch how we go over it later. And yeah, that's the advice I give. But yeah, I'm gonna leave that there now. I'm gonna stop waffling. Tomorrow I won't be doing GCSE. My schedule. Wednesday I was supposed to do A level again. However, obviously the GCSE exams on the next day on Thursday, so I'll do GCSE stream. But I won't be doing a past paper. I don't think I've done a lot already. I think you get the gist of it now, right? I've done 3 past papers. They're all mostly similar. Nothing too out there. So what the aim is on Wednesday, the next stream, I'm gonna compile the typical questions that I've seen come up. So it'd be almost like a predicted paper in a way. I'll compile the 20 or so questions that I've seen that in the style of what seems to always come up routinely on these non-papers, calculated papers. And then I'll go over it. So it'll be like a non-calculated predicted paper almost. So I'd want to be tuned for that. But yeah, I'm going to leave that there now. Thanks. Hopefully this helps. Obviously appreciate the comments or whatever. But I'm going to leave that there then now. Cheers and good luck in your exams, obviously, biology or English or whatever, whatever. Good luck in all of that. But I shall see you next time. Oh, thank